So today we're going to be solving problem 16 from the 2018 AMC 10. And this problem is going to be about geometry and number theory. So the solution is going to be a combination of geometry and number theory, which is pretty interesting because, okay, so here we can clearly see that it's a geometry problem, but then we're also dealing with integers. So it's basically just geometry and number theory, which is pretty interesting. So let's start the problem then. So right triangle ABC has leg lengths AB equals 20 and BC equals 21. This means that the right triangle ABC has a right angle at B. There we go. And AB is equal to 20. And BC is equal to 21. Okay. Oops. So I shouldn't have done that. And so, including AB and BC, how many line segments with integer length can be drawn from vertex B to a point on hypotenuse AC? So, pretty confusing, I guess. So you can just go ahead and just count all of them, just draw all of those integer length line segments. But no, that's not elegant. So we're gonna try and make this a bit easier to solve. We're gonna be strategic here. So, firstly, since it's a right triangle and we have the leg lengths, what do you want to do with this? What is the first thing you will want to do? You're going to want to find the hypotenuse. So, we're not sure if this is going to help, but let's try it out. So, we know that 20, 21, and 29 is a Pythagorean triple. So we can clearly see that AC will be equal to 29. So it'll be good to know your Pythagorean triples because it saves a lot of time when dealing with right triangles. So now we're gonna look at this thing here. So we can clearly see that the shortest possible line segment that is drawn from vertex B to a point in AC will be the altitude from B to AC. So the shortest possible line segment drawn from vertex B to a point in AC will be the altitude drawn from point B to line AC. So here, let's say that this is the altitude. Yeah, that was what I was trying to draw here previously. And the right angle here. So let's say the foot of the altitude from B to AC is point P. Let's call that P. So then now let's try to find the length of BP. So we know that the area of triangle ABC is equal to AB times BC over 2, which is 20 times 21 over 2. But then we can also calculate the area of this triangle in another different way, which is AC times BP. So AC is equal to 29. So 29 times BP is equal 29 times BP over 2. So here we get that BP will be equal to 20 times 21 over 29. So let's write that down. BP is equal to 20 times 21 over 29. And we can clearly see that 20 times 21 is not a multiple of 29. So BP is not going to be an integer, which kind of sucks, but okay, but we only want to deal with integers here, so we're going to put BP in an interval between two integers. So here we can see that BP will be around 14 point something. So BP is going to be between 14 and 15. So BP is going to be the integer lengths 14 and 15. So now we already calculated the approximate value for BP. So now we're going to try to count these line segments now. And as we solve this problem, we're going to realize that this piece of information was pretty important. So let's say that these line segments will be line segment BX. It will be BX, where X is the point on AC. So we can see that as X moves along changes positions along the line AC, the length of BX is going to vary. So what does that tell us? So we can just look at the different position. We can basically just observe how the change in position of the position change in X affects the length of BX. So first, so we're going to split this into two cases. So first, let's do color blue. Okay. There we go. And okay. So let's deal with the case when that X is really messy. As X moves from point A to point P, what will happen to the length of BX? So let's kind of observe this. So we look here let's say this is BX. So like this, it is drawn from B to AC, and then X will be the point on AC. So we can clearly see that as X moves from A to P, this is so hard. As X moves from A to P, we can clearly see that it strictly decreases the length of BX. So the length of BX decreases from a length of 20 to the length of BP, as you can see here. It decreases from a length of 20 to the length of BP. And we know that the length of BP is between 14 and 15. It's like 14 point something. But we only want to deal with integer lengths here. So we're just going to say that this length is going to range from 20 to 15 as X moves from A to P. So we can see here, so we can just write this down. So we know that as X moves from what is wrong with my pen today? So as X moves from A to P, we can clearly see that the length of BX is going to decrease from 20 to 15. So as X moves from A to P, the length of BX is going to hit all the integer lengths from Okay, I'll say that again. So as X moves from A to P, the length of BX is gonna hit all the integer values, 20, 19, all the way up to 15. There you go. So now let's deal with the other case. Okay, so this time X is gonna move from P to C. X is going to move from P to C. So here, it's a pretty similar scenario, I guess. So as X, okay, I'll draw that again. So as X moves from P to C, we can see that the length of BX is going to strictly increase. It's going to strictly increase from the length of BP to the length of BC, which is 21. And we know that BP is 14 point something, and we only want to deal with integers here. So we're gonna just say that this line segment as X moves from P to C is gonna range from a value of 15 to 21. So as X moves from P to C, the length of BX is gonna increase from 15 to 21. So let's write that down again. So we can see that as X moves from P to C, the length of BX is going to increase. It's going to increase from 15 to 20, which means that so as X moves from P to C, the length of BX is going to strictly increase from 15 to 20. So it's going to hit all the integer values, 15, 16, all the way up to 20. That's neat. Okay. Oh, wait. Not 20. I'm sorry. It's not 20. That is 21 because it's the length of BC. So it's going to hit all the integer lengths, 15, 16, all the way up to 21. Okay, that's a bit more right. So here, for all BX, for all the line segments where its endpoint lies between P and C, and between A and P, I'm sorry. So for all line segments where its endpoint lies between A and P, the length of those line segments would be 20, 19, all the way up to 15. So the number of line segments with integer length so the number of those line segments will be the number of numbers from 20 to 15, which is 20 minus 15 plus 1, which is equal to 6, I think. Yeah, 6. And for the other case, similarly, for all the line segments with integer length, where its endpoint is between P and C, its lengths are going to be 15, 16, all the way up to 21. So the number of those line segments would be the number of numbers from 15 to 21, which is 21 minus 15 plus 1, which is equal to 7. So then here we're going to have a total. We're getting our answer now. We're going to have a total of 6 plus 7 equals 13. So 6 plus 7 equals 13. 13 line segments with integer length that can be drawn from vertex B to a point on hypotenuse AC. And here we see our answer. So that was a very elegant solution. So some number theory dealing with integers here. Yeah, so hope you enjoyed this video and got the solution. And yeah, see you in the next videos.